Before the world knew Sweden for Spotify or IKEA, it was this steel company, Sandvik, that was quietly changing the world from deep inside the earth. This is a story about a company that always moved forward, from the first steel mill in a frozen Swedish village to inventing tools that mine deeper, cut harder, and last longer than anyone else's. They built the drills that carved the tunnels, the tools that built the factories, and the steel that built the modern world. And it all started with a bankrupt entrepreneur who gambled everything on a new way to make steel, a method so radical even his partners walked away. This is the story of Sandvik, the steel company that refused to stand still. In 1857 Sweden, Göran Fredrik Göransson heard about Henry Bessemer's failed steelmaking process. While others dismissed it as impractical, Göransson saw potential. His international travels through Europe and America gave him a perspective others lacked. He recognized this flawed technology could revolutionize steel production if modified correctly. May 20th, 1857 is an important date in the history of Swedish steel. That is the day it was confirmed that Göransson from Gävle in Sweden had bought a fifth of Henry Bessemer's incompletely developed patent. Experts claimed industrial-scale steel production was impossible. The process couldn't maintain high temperatures and produced brittle steel filled with air pockets due to impure pig iron. But Göransson's critical breakthrough came when he increased the air blast strength, successfully producing industrial-scale steel by 1858. His Swedish operation outperformed Bessemer's English attempts, making mass-produced steel economically viable worldwide. This success led Göransson to found Högby Stål Järnverks AB near Sandviken in 1862. He chose the remote location strategically for its iron ore, forests, and water power. There he built more than a factory. He created an entire industrial community with worker housing, schools, and hospitals in previously uninhabited land. The early years brought turbulence. In 1866, after just 4 years, the company went bankrupt when Göransson's main backer, Johan Holm, faced financial troubles. But in 1868, Göransson's son, Anders Hendrik, restructured the business as Sandvikens Järnverks AB. The Sandvik name debuted publicly at the 1876 Centennial International Exhibition in Philadelphia. Sandvik's early products built its reputation. Specialized drill steel became its first successful European export by 1878. The company also produced railway tracks, springs, wire, and precision components, each reflecting Göransson's commitment to solving industrial problems through innovation. Göransson implemented unusually progressive worker policies, insisting families received equal rights to management. "They have paid the same amount for their seats as the rest of us," he declared, extending this philosophy to housing, education, and healthcare. These practices set a precedent for Scandinavian labor relations. By 1901, Sandvikens Järnverks AB listed on the Stockholm Stock Exchange, transitioning from family enterprise to public company while maintaining its core values. This provided expansion capital and marked Sandvik's evolution into a modern corporation. Göransson's legacy blended technological risk-taking with social responsibility. His Bessemer process modifications unlocked cheap steel for industrialization, while his worker welfare programs proved factories could be both profitable and humane. This dual focus became Sandvik's DNA, outlasting competitors focused only on short-term gains. Early challenges shaped Sandvik's resilience. The 1866 bankruptcy taught financial management lessons, balancing bold innovation with fiscal responsibility. Unlike contemporaries who viewed workers as expendable, Göransson invested in them as assets, giving Sandvik an edge in attracting skilled labor. Product development targeted practical needs. Sandvik's rock drill steel solved mining challenges, while precision components met railroad industry demands. Rather than mass-producing generic goods, Sandvik specialized in engineered solutions, creating real customer value. International expansion began early. The 1876 Philadelphia expedition introduced Sandvik to American markets, with its steel drilling equipment used in U.S. mines within 2 years. This global presence buffered against domestic fluctuations and positioned Sandvik as a worldwide supplier. Adaptability showed in the transition from charcoal to coal power as supplies dwindled. Rigorous quality control also differentiated Sandvik. Its steel's consistency built trust where competitors struggled with variable quality. By 1900, Sandvik had survived crises, established global markets, innovated processes, and developed a skilled workforce. More importantly, it established a pattern: identify industrial problems, develop material solutions, and build delivery infrastructure. Göransson's vision proved precedent. His experimental steelworks became a model for responsible industrial development, influencing Scandinavian labor relations for decades. The technological breakthroughs enabled previously impossible construction projects, creating an institution that would innovate for over 160 years. At the century's turn, Sandvik was uniquely positioned, diversified in products and markets, with a culture balancing innovation and stability. This foundation would prove crucial facing 20th century challenges: world wars, depressions, and technological revolutions. The early principles, technical excellence, social responsibility, and global vision, provided the compass to navigate each new challenge successfully. The year 1901 transformed Sandvik from a family steelworks into a modern corporation through its Stockholm Stock Exchange listing. This influx of capital funded revolutionary innovations, starting with steel conveyor belts that outperformed rubber and textile alternatives in harsh mining conditions. The belts became essential for continuous material transport with minimal maintenance. Sandvik's 1907 hollow drill steel breakthrough demonstrated its engineering-first approach. Unlike competitors' solid drills, these tubes featured a central bore for injecting flushing fluids, cooling bits while ejecting rock cuttings. Miners achieved unprecedented drilling depths and speeds, establishing a new global standard. This willingness to rethink conventional solutions became a Sandvik hallmark. When Carl Fredrik Göransson assumed leadership in 1920, his US-educated perspective brought scientific rigor to metallurgy. Despite post-World War I economic instability, he championed Sandvik's 1921 development of Sweden's first stainless steel. The expanded steel laboratory enabled this achievement, just as global demand surged across industries, from surgical instruments to railway tank cars requiring corrosion-resistant materials. Göransson's Wednesday Club in the 1920s exemplified Sandvik's progressive culture, uniting management and workers to solve production challenges. This collaborative spirit fostered both innovation and workforce loyalty, a competitive edge when other manufacturers faced labor unrest. The 1934 Pilgering process marked another milestone as Sandvik became Europe's first cold-rolling tube producer. This single-operation technique improved dimensional precision while slashing production time, differences visible to industrial customers' naked eyes. Like interlocking gears in a precision machine, each innovation built upon the last. World War II forced adaptation as exports halved, but military contracts for grenades maintained production. Sandvik used this period to refine cemented carbide expertise, knowledge that would dominate post-war manufacturing. Wilhelm Haglund's 1942 push into carbide tools birthed the Coromant brand, whose durable cutting tools soon transformed global factories. Post-war expansion saw new facilities in Himo and Västberga, while strategic subsidiaries extended Sandvik's reach across Europe and North America. This global network delivered local manufacturing with worldwide technical support, an unbeatable combination during Reconstruction's tool demand surge. Sandvik's quality systems became legendary. Its advanced materials laboratory subjected every steel batch to rigorous testing, ensuring reliability for customers whose reputations depended on consistent performance. Financial prudence from 1866 near collapse allowed continued research and development even during the 1930s depression, when competitors retrenched. The cemented carbide division exemplified Sandvik's persistence. Engineers developed proprietary machining techniques for this brittle material, creating tools that outlasted conventional options. By 1950, these innovations were revolutionizing metalworking worldwide. Mining solutions evolved from simple drill bits to integrated systems addressing real operational challenges. Faster penetration, extended tool life, reduced downtime. International growth followed a deliberate pattern, with each acquisition filling specific technical gaps rather than pursuing scale for its own sake. By mid-century, Sandvik had become a multinational technology leader, its product lines interconnecting like components in a well-oiled machine. The foundations laid during these decades in material science, manufacturing processes, and global operations would drive future breakthroughs like the 1957 T-Max tool holder. This evolution appeared seamless because it adhered to enduring principles: invest in people, solve real problems, and relentlessly improve technology. When you use stainless steel appliances or benefit from modern mining infrastructure, remember, these conveniences exist because a Swedish company kept advancing while others stood still, and this was merely Sandvik's first act. The 1950s opened with Sandvik's T-Max tool holder changing factory floors everywhere. This invention let machinists switch cutting bits in seconds instead of minutes. But what few realized was this tool marked just the start of Sandvik's biggest transformation yet. Over the next 30 years, the company would remake itself completely, from a Swedish steel specialist to a global technology leader. Post-war factories needed better tools to keep up with demand. Sandvik had spent World War II improving cemented carbide technology while others focused on wartime production. Now that preparation paid off. Cemented carbide tools cut faster and lasted longer than steel, but Sandvik was still seen as a steel company. Leadership faced a choice: stay with what made them successful or bet everything on this new material. They chose the gamble. In 1962, Sandvik opened its first overseas cemented carbide plant in the UK. Other factories followed: Germany, France, the US, even South Africa. Each facility tailored products for local industries. German plants made precision components for machine tools, while American facilities focused on mining equipment. Sandvik didn't just export, it became part of each market. Then came the 1969 gamma coating breakthrough. By adding a microscopic titanium carbide layer to cutting tools, Sandvik engineers tripled tool life. Machinists could now cut harder metals at higher speeds without stopping. Factories increased output while cutting costs, a game-changer for production managers struggling with downtime. Sandvik made a symbolic change in 1972, shortening its name from Sandvikens Jernverks AB to Sandvik AB. Steel was now just one part of a broader technology portfolio. The new name signaled this wasn't grandfather's steel company anymore. Acquisitions expanded capabilities strategically. The 1976 purchase of German toolmaker Hertel brought new machining techniques and a stronger foothold in Europe. Other deals added rock drilling expertise and automation know-how. Unlike competitors buying just to grow, Sandvik targeted additions that strengthened the whole business. When the 1973 oil crisis hit, most industrial firms slashed research budgets. Sandvik did the opposite. While others retreated, it kept investing in technology and global facilities. This gamble paid off. When economies recovered, Sandvik had new products ready while competitors scrambled to catch up. By 1980, the transformation was complete. What began as a single steel mill now operated in 14 countries. Most importantly, Sandvik had become a different company. Instead of selling materials, it provided solutions. Engineers worked directly with customers to solve manufacturing challenges. The numbers showed the shift. In 1950, cemented carbide was 15% of Sandvik's business. By 1980, it was nearly half. Mining equipment had grown equally important, while specialty steels became one segment among many. Worker training kept pace. Sandvik established technical schools near factories, teaching not just machine operation but material science. This deep understanding set Sandvik apart. Competitors could copy products, but not the knowledge behind them. Quality reached new heights. X-rays checked for microscopic defects. Lasers measured edges to millionths of a meter. Aerospace and automotive customers depended on these tolerances. Lives literally rode on them. Sandvik rethought global service. Local plants manufactured core products while drawing on central research and development. Headquarters supplied advanced materials, while regional factories adapted solutions locally. Environmental efforts emerged quietly. Sandvik reclaimed grinding sludge to recover tungsten and implemented closed-loop water systems. These weren't PR moves, just practical ways to cut waste and costs. Standardization created efficiencies. Tool holders from Germany fit machines made in Japan. Modular designs gave manufacturers flexibility while simplifying inventory. The workforce globalized. Management blended local talent with Swedish experts, creating a cross-pollination of ideas. Brazilian engineers might suggest improvements later adopted in Finland. By decade's end, Sandvik had mastered reinvention. The steel producer of the 1950s was now a global problem solver. This mindset, helping customers succeed, not just selling products, would drive future growth. Looking back, the change appeared seamless. No massive layoffs, no dramatic rebranding. Each step built logically on the last, guided by the same principles. Technical excellence and practical thinking applied to ever wider challenges. This pivot created the modern Sandvik, no longer tied to one material, product, or market. While most 1950s competitors vanished, Sandvik thrived by refusing to stand still, a lesson that would prove invaluable in the decades ahead. The 1980s opened with Sandvik straining against its own success, a steel giant shackled by centralized control. With 30,000 employees across 14 countries, all reporting to Sweden, decisions moved slower than the markets they served. Asian competitors gained ground as digital technologies reshaped factories. The old model was breaking. Percy Barnevik's 1983 CEO appointment brought radical change. He shattered Sandvik into 7 autonomous units overnight, each controlling its own strategy, profits, and operations. The mining team could now respond to customers without Swedish approval. Carbide engineers pursued breakthroughs independently, yet all units still shared Sandvik's technical knowledge and quality standards, the glue holding this new federation together. The results stunned even optimists. By 1988, the Carbide division created PVD-coated inserts that handled previously impossible speeds. A titanium nitride coating, just 2 to 4 microns thick, extended tool life by 300%. Factories worldwide could suddenly machine tougher materials faster with less downtime. When Eastern Europe's borders opened in 1989, Sandvik acted decisively. They didn't just sell tools, they rebuilt entire production systems. Polish steel mills got Sandvik automation alongside traditional equipment. Czech factories received training programs with their new machines. These partnerships became blueprints for emerging market strategies. Multi-layer coatings arrived in 1992, each stratum engineered for specific heat or wear resistance. Soon, single factories produced hundreds of specialized tool variants, all meeting identical quality thresholds. The 1997 Tamrock acquisition transformed Sandvik's mining business. Overnight, they offered complete systems, drills plus bits, combining Tamrock's mechanical designs with Sandvik's material science. That same year's Canthal purchase added heating technology, enabling new high-temperature alloys for industries from glassmaking to food processing. But Barnevik's boldest move came in 1999, selling the profitable saws and tools division. Consumer products no longer fit Sandvik's industrial focus. This surgical cut freed $150 million annually for core R&D, proving that even cash cows could be sacrificed for long-term strategy. By 2000, Sandvik had streamlined to 3 global divisions: tooling, mining, and specialty steels, each with local decision-making. The chaotic sprawl of the 1980s was now a precision instrument. Revenues grew 8% annually despite divestitures, while profit margins expanded from 6% to 12%. Decentralization's genius lay in balance. South African mining tools differed from Canadian versions, yet both used shared metallurgy breakthroughs. Eastern Europe became Sandvik's innovation lab. Modernizing Polish mills revealed how traditional steelmaking could integrate with automation. Czech projects proved the value of combined equipment and training packages. These lessons later guided expansions into Asia and South America. Quality systems leaped forward. Automated measurement reduced human error by 40%, while customer feedback loops let engineers refine designs based on real-world performance. Environmental efforts went beyond compliance. Tungsten carbide recycling began a decade before regulations required it, cutting costs while future-proofing operations. The workforce transformed alongside technology. Technological training centers taught the science behind machines, empowering workers to suggest improvements. Brazilian engineers rotated through Swedish labs, then applied insights back home. This cross-pollination sparked unexpected innovations. Customer relations deepened from transactions to partnerships. Sandvik engineers worked on factory floors solving production challenges. One such collaboration revealed the need for faster titanium machining, leading to the breakthrough PVD coatings that later dominated aerospace tooling. Financial discipline matched technological ambition. Strict capital allocation ensured research and development investment solved real customer problems. No pet projects survived on corporate goodwill. Success metrics shifted from production volume to customer impact. A new tool saving 15% machining time mattered more than units shipped. This 20-year transformation repositioned Sandvik from steel producer to solutions provider. When digitalization arrived in the 2000s, their decentralized structure proved ideal. Business units could adopt new technologies rapidly while leveraging group R&D. The stage was set for autonomous mining systems and AI-driven tool optimization. Historians would later note the timing's perfection. Sandvik's restructuring concluded just as industry stood on the digital brink. By making painful cuts and bold bets, they didn't just survive upheaval, they helped define it. The numbers told the story. 12 consecutive years of margin growth, with technologies embedded in customers' core operations worldwide. The giant had not just broken its chains, it had learned to dance. The year 2001 marked a quiet revolution at a Finnish nickel mine where Sandvik's new AutoMine system operated heavy equipment without human operators underground. This represented a complete rethinking of mining operations, like a conductor assembling a digital orchestra where each machine played its precise role in perfect harmony. While competitors focused on incremental upgrades, Sandvik bet on automation that would redefine the industry. By 2004, this symphony of machines was performing commercially at Codelco's El Teniente copper mine in Chile. Workers moved from dangerous underground environments to control rooms, immediately improving safety. But the real surprise came when automated loaders maintained steady 24/7 production, outperforming human-operated equipment. The system's success proved automation could deliver both safety and productivity gains. Sandvik amplified its capabilities through strategic acquisitions. The 2002 purchase of German toolmaker Walter AG expanded their cutting tool portfolio, while providing machining data across additional industries. Combined with their Seco Tools division, Sandvik gained unprecedented visibility into global manufacturing processes. When the 2008 financial crisis hit, Sandvik doubled down on innovation while others retreated. Their development of Coromant silent tools, vibration-dampening tool holders for precision aerospace and medical components, positioned them perfectly for the coming recovery. This commitment to research and development during downturns became a hallmark of their strategy. By 2010, AutoMine had evolved from a single instrument to a full orchestra. Sandvik became the first to offer unified traffic management for autonomous drills, loaders, and trucks. At Sweden's Boliden Galpenberg mine, automated loaders worked accident-free for 20 years while handling most production, a testament to the system's reliability. The 2017 launch of Sandvik's digital machining division marked another movement in this symphony. Their Coro Plus tool library provided real-time cloud updates, allowing factory managers to optimize entire processes remotely. Vibration analysis from silent tools now predicted maintenance needs, preventing failures before they occurred. Sandvik's 2021 acquisition of CAD/CAM specialist Cambrio added another section to the orchestra, enabling complete digital workflows from design to production. The 2022 spin-off of Alema completed their transformation into a focused technology provider, freeing resources for digital and automated innovations. Today, this digital orchestra plays across global industries. Sandvik's automated mining systems connect not just to operators, but to each other, coordinating movements within complex underground networks. Safety improvements have been dramatic, with mines reporting significant reductions in accidents and injuries. The manufacturing side performs equally impressively. Sensor-equipped tools feed performance data to the cloud, creating closed-loop systems that continuously optimize based on real-world results. This digital integration helps manufacturers reduce material waste by up to 80% in some applications while cutting energy use. The financial impact shows the power of this approach. Digital offerings generated SEK 5.1 billion in 2024 revenue, on track for SEK 6.5 billion by 2025. Their manufacturing co-pilot, developed with Microsoft, uses generative AI to optimize processes in real time, the latest movement in Sandvik's ongoing innovation symphony. Worker training has adapted to this digital reality, blending data analysis with traditional skills. Supply chains have digitized too, with connected systems monitoring inventory and automatically triggering replenishment. These innovations reduce downtime while cutting excess inventory costs. Cross-industry synergies create unexpected harmonies. Mining automation techniques find applications in construction, while manufacturing algorithms improve medical device production. Sandvik's broad portfolio enables narrowly focused innovations competitors can't match. Looking ahead, Sandvik continues composing the future of digital industry. Autonomous systems will replace dangerous work, AI will optimize processes, but the core principle remains unchanged since 1862. Solve industrial problems through technical innovation. The steel mill of the past couldn't imagine today's global technology leader, but both share the same innovative spirit that keeps this digital orchestra playing ever more complex and productive symphonies. For 160 years, a Swedish company you've probably never heard of has shaped how we build our world. Sandvik's components exist in everything from skyscrapers to smartphones, yet the name remains unknown to most. This paradox defines Sandvik, a hidden giant whose innovations enable progress while staying invisible to the end user. Imagine the gears inside a clock, small, precise, unnoticed, yet essential to keeping time. Sandvik operates similarly, powering modern life through three transformative innovations: precision steel that birthed mass production, carbide tools that cut machining times in half, and automated mining systems that extract resources with surgical accuracy. These breakthroughs didn't seek applause, they solved real problems quietly. This anonymity reflects Sandvik's philosophy. While tech companies chase headlines, their tools have reduced factory material waste by 80%. Their mining systems boosted productivity 30%. Modern Sandvik tools last 4 times longer than 1950s models. These numbers aren't marketing, they're measurable impacts echoing through workshops and mines worldwide. Göran Fredrik Göransson's 19th century vision still guides them. His company towns provided housing and schools when competitors exploited workers. Today, that same thinking recovers 80% of materials from used tools. Sustainability isn't a trend for Sandvik, it's their operating system. Their fingerprints appear in unexpected places. The alloy in your hip replacement, originally developed for drill bits. Wind turbine blades withstand storms thanks to materials created for offshore rigs. Even Mars rovers rely on Sandvik's specialty steels. When you solve fundamental problems, solutions cross industries naturally. What's astonishing is their consistency through radical change. From steelmaker to digital solutions provider, Sandvik kept one question central: what challenge are you solving? This focus helped them outlast competitors who clung to the past or chased fads. Today's global network spans 150 countries, sharing knowledge as much as products. A breakthrough in Chilean copper mines might revolutionize German car factories months later. Local teams adapt technologies while tapping into worldwide expertise, like a neural network for industrial problem-solving. Walk through any modern factory and you'll witness Sandvik's legacy. Their diamond-tipped drills shape skyscrapers. Their automation protects miners, yet their logo rarely appears. Their impact lives in what products enable, not branding. Take their circular economy programs. Used tools get reborn as new products worldwide. This isn't greenwashing, it's the same practical mindset that built those company towns. Waste represents unsolved problems, and Sandvik engineers live to solve them. Financial stability fuels their long-term thinking. Unlike startups chasing quarterly growth, they've maintained R&D through wars and recessions. New ideas take years. Sandvik structures itself to wait. Worker training bridges old and new. Veteran machinists now interpret data analytics alongside metal properties. Technical schools near plants teach digital skills alongside traditional craftsmanship, a culture that adapts without forgetting its roots. Their CO2 goals reveal the same pragmatism. Cutting emissions 50% by 2030 seems bold, until you realize they've already done it while growing business. The solutions exist, implementation just requires systematic effort. Partnerships with Microsoft on AI tools show how they integrate new tech without losing focus. They don't chase trends, they assess what actually solves problems. Most telling, competing manufacturers often use Sandvik patented methods unknowingly. The company prioritizes widespread adoption over restrictive control, progress over patents. Corporate Knights named them a top sustainable company, but you won't hear bragging. When you've transformed industry for 160 years, the work speaks for itself. Now targeting net zero by 2050, they'll get there through countless small improvements. Better insulation here, optimized logistics there, monumental impact delivered methodically. Our culture celebrates flashy startups, not century-spanning reinvention. But next time you board a plane or use a smartphone, remember, Sandvik's quiet revolution makes it possible. The gears kept turning, unseen yet essential, as they begin their next 160 years of solving problems we haven't even discovered yet. Sandvik's 160-year journey proves industrial progress thrives on constant reinvention, not single breakthroughs. That same innovative spirit that saved them with hollow drill steel in 1866 now powers AI-driven mines, all while staying true to Göransson's original vision. Though their tools often go unseen, they're everywhere. In your smartphone's metals, the wind turbines generating clean energy, and the subway tracks beneath your feet. Göransson's belief that technology should serve both industry and humanity now echoes in every sustainable solution they pioneer. As we stand at this crossroads, what industrial challenge matters most to you? Maybe it's cleaner steel production, smarter recycling systems, or greener mining tech. Share your vision in the comments, because the next 160 years of progress will be written by today's ideas. So, here's the real question. Which invisible innovation will shape your world next? The answer starts with this conversation.